All right, I am back for part two. Um, and my code has not changed in the slightest since I was last on here. So, okay, to kind of recoup here, we have a process here where we're counting how many Satoshis are coming into and out of the transaction, figuring out what the fee should be to ultimately calculate how many Satoshis we need to add as an input to this transaction. Then the part where I didn't get to is we are going to build a funding transaction. And that funding transaction is going to have one output that is exactly the amount of Satoshis we need to add as an input to our to their transaction that we're actually funding. So again, I guess just step back a little bit since I kind of got off lost the train of thought a little bit in the last approach through. This is a transaction that we're trying to fund that is completely signed as sig hash all. So all of the inputs that are in this transaction, the signatures are based on the fact on none of the outputs changing, which means we can't just put any old UTXO as an input and put a change output to put the change back to ourselves. Because by adding that change output, the sig hash all the output hash that all the inputs have been signed against is not the same anymore. And so essentially, if we add that change on, we've changed the transaction, which means we would need to regenerate those signatures. So if this is a process where a server is going to be receiving a transaction, sticking a UTXO on it and broadcasting, or sticking a fee, a mechanism for paying for fees on it, and then broadcasting it on. Okay, so we've now gone through. We've got the amount of sats we need. This other stuff we'll get back to in a second. So we're going to create a fund transaction. Transaction dot, was it new transaction? Okay, so this transaction, we're going to say fundtx dot add output. Oh, I just realized we need to do this lower. So let's do this. I'm going to rearrange things a little bit. I'm just going to comment this all out for now so it doesn't confuse me. All right. So we've got a new funding transaction. We're going to add two outputs to this funding transaction. One of them is going to be for the amount of sats we needed. And the script is, oops. And this is locking the script. Okay, so we have our empty transaction. We had one output to it at output 0 that is however many Satoshis we needed. Then we're going to go fund tx.add output. Actually, let me just copy this. So on the second output, we are not going to specify the number of Satoshis we need. We're just going to set the change variable set to true. So what that means is when it goes to actually kind of sign and update this transaction, it's going to calculate at that point of time what the fees and change are going to be, and it's going to populate the Satoshis on this change output with the appropriate amount of Satoshis. So now let's get down to this code. Okay, so now the transaction that I'm actually trying to calculate how much I need to fund for is this new fund transaction. So what I was doing before was kind of in the wrong scope, the wrong Yeah, I was confused. So I think I need one more. Missing some brackets here. Okay, so this is the end of this for. Then we've got this else. And oh, what do I got here? So this yellow is closed there. Goes there. That's closed. Okay. So basically, I need to add enough inputs to this transaction that it can cover paying this many Satoshis out and the transaction fees for this transaction. Okay, so I've got my fund transaction. Okay, so I've got my out point. I've locked my out point. And I'm adding that output to my transaction. Now, in 99% of times, this one UTXO is going to be all I need to add, and this all will be fine. But sorry. But it's possible it's not enough, and I need to let this loop go and grab another one and add another UTXO to this input. So how do I figure out if I have got enough UTXOs now? Let's take this logic. Okay, so that sets in was actually about that other transaction. Sets in. So I probably want to start fresh with that here. Sats in equals 0. Sats out equals 0. Actually, sats out equals sats needed. So I've added my Satoshis. I get my size. This should be the size of fund TX. Ah. So in order for me really to be sure, like if I just take the size of this transaction before I've signed it, that's not going to give me an accurate representation of how big the transaction is going to be after I sign it. I believe, though, if I call, let's go back to the Go SDK for a second. And there is a transaction, I believe it's called fee. No, fees. Where is this? Fees. Okay, fee method here on the transaction. So it is going to call compute fee. What does compute fee do? Oh, that's based on the fee model. Okay. So, well, actually, let's go to the sats per kilobyte fee model. Compute fee. Go all through all my inputs and look and see if there is an unlocking script. If there is, I measure it. If there's not, I call estimate length from the script template. I add that on. Okay, so this method right here is pretty much doing exactly what I want. So, compute fee. And this is calling estimate length. So this estimate length on the script templates kind of takes care of the fact that I don't actually have this signed yet. I don't actually know how big it's going to be. Well, this estimate length, that's exactly the point of that, is the script template can tell you how big it's going to be. So let's create here a create, for now I'm just going to put it right here. We're going to say fee model. And this is, that's the TypeScript one. Where is my sats per KB? So this is in fee model dot satoshis per kilobyte. Package fee model. What is wrong with my import? Fee model, transaction, fee model. Oh, it fixed itself. Let's just do a little go mod tidy here. Okay. No required module provides packaging. Bitcup. Bitcoin SV, Go SDK, transaction, fee model. Fee model. What is going on here? Let's see where else we reference this in any of our examples or anything. Nope, nowhere. Huh. Well, this is fun. What is going on here? I guess first of all, let me check what version of the Go SDK I'm using in here. I'm pretty sure it's very modern. Go SDK 1.1.14. Oh, I'm not even in. It shouldn't matter what my local branch is, but did I change something? What did I change? Oh, we'll fix that over there as well. Did something change here? Go back to sats per kilobyte. Still in fee model. That is in transaction. Transaction fee model. Huh. Oh, there it is. There we go. I have no idea what happened there. Oh, it's because the directory name has got an underscore in it. I've not figured out the best way to really name packages. Naming stuff's hard in general. I just stink at it. All right. So we have a Satoshis per kilobyte. Okay, so let's actually just change this up then. Means I don't actually need to do any of this stuff. Well, I do need that one. All right. So I have a fee. So let's go back to this. So this is going to tell me how big of a fee I need for my transaction. And it does look at okay, this has no concept at all of how many inputs or outputs are already in that transaction, which means copy this. Let me undo a little bit. Put those things back, and then let's go back here. So if that's in is greater than sats out plus fee returned. What's wrong with my sats in here? This is probably, oh, oops. Actually, I'm going to move this down further. Okay. So I'm going to move this down here. That seems a little cleaner. Okay. I add up all my inputs. I add up all my outputs. I calculate what the fees should be. If I don't need any more fees, I return them, blah, 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 blah. Okay. So down here then, I need to find out, I've added the input in there. So we're going to go copy this again. Don't need the size. Okay, so else if sats in is greater than or equal to the sats out plus the fee that I'm going to break. Okay, so all this is really saying is if I have more sats in my transaction right now than I have the Satoshis out plus the fee. So if I don't need to add any more inputs for this transaction to work, then I break out of my for loop here. If I need to add an additional input, it'll go in, it'll do the exact same thing again, it'll find another out point, it'll try to lock it. If it can't lock it, it'll go again, find the next one. So ultimately where we're going to get to a point is when we get out of this for loop, the transaction should be adequately funded. Now, from this point, let's see if I want to say, forget the if right now, fundtx.fee. So this fee method is going to go through and essentially calculate everything and update this change output to have the appropriate amount of Satoshis in it. Pretty sure that returns an error. What does fee return? Okay, it takes a fee model, takes a change distribution, and it returns an error. Okay, so let's go to this part here. Change distribution. That is essentially a constant. Oh, I wasn't in the wrong project. Okay, so we're going to pass here is transaction.change distribution equal. What is wrong with my fee model here? Fee model cannot use fee model. What? Oh. It's got to be a pointer. Okay. So now I'm going to sign the funding TX. Okay, so at this point right here, I should have a transaction called fundTX that is entirely ready to go. It has whatever inputs it needs to be able to cover the outputs of my sats needed here. And then it just returns everything back to itself in change. So that is all that this transaction does. So at this point, boom. Am I in the right spot? Else. Where was fundTX? FundTX is right here. Okay, so I'm going to go outside of this else. And we're going to say TX, which is our main transaction, add input. And I'm going to say transaction input. Oops. And that input is going to have in it, what does I don't think that's what I want to do. I think I want to do tx.add input from tx. My source transaction is fundtx. My vout is 0. And the unlocking script template is unlock. So just to go over that part again. Where is it? Right here. So we are creating a locking script using the P2PKH template. We're creating an unlocker from, or an unlocking script template from the P2PKH script template. And those are going to be the same for all outputs to that address and inputs from that address. So this is really all I need to do here. And then I should be able to go tx.sign. Okay, so from a transaction building standpoint, everything I need is done right now. But I do want to point out one thing here. So this transaction I'm returning from this method, so this fun transaction that I created within this has not ever been broadcasted anywhere yet. And it needs to be broadcasted in order for it to actually exist on the chain. And so the main transaction I'm trying to fund here is dependent on this funding transaction. But because of how the new SDKs work, this add input from TX, where I'm passing this transaction in as a reference for my input, there are mechanisms in the new SDKs and in the new broadcast mechanisms and things like that to use this beef format for transaction broadcasting. So what beef does is it takes not just one transaction, but a transaction and any of the input transactions those point to, and any of the input transactions that those go to. So any unbroadcasted transaction or any unmined transactions should become part of this whole beef format. And I will say there's, for like the whole beef solution, there's a lot of bits and pieces implemented all over the place. But one of the things I'm going to have to kind of try to figure out here is, so I could take this transaction and I could go through two different broadcast mechanisms. I could say, okay, I need to broadcast this funding transaction. And then after that, I need to immediately broadcast my actual transaction itself. And I may still end up doing that. I got to do some digging into exactly the best way to do that and where the kind of the most, what the easiest way to do this is. I have not actually yet broadcasted a beef transaction to ARC. But that's going to be something for probably a little off-stream research before I even dig into that. But anyway, so my method here, let's just review this one more time and then I'll end the stream. We have a fun transaction method. It takes, so this index context is essentially, it's just the transaction, but parsed in such a way that all the inputs have been loaded up so we know what their Satoshis are. You need to use this tool to create a process similar to this. I'm just using it because it already has, it's part of this solution I'm already working on. It already has all the parsing. It already has all the looking up of the inputs and everything like that. So my index context here is the transaction itself with some lookups already done. So I look through all the inputs or the spends in that to figure out how many Satoshis were coming into this transaction. I loop through all the outputs to find out how many Satoshis are coming out of this transaction. Actually, I'm going to do this slightly differently just to be a better example. Okay. Rather than going through my index context options, which again is very, I'm just going through the actual transaction outputs. The inputs, I still need them looked up and populated, so I'm going through my index context for that. But okay. So I figure out how many inputs and outputs I have to my transaction. I create a fee model class or instance, figure out what the fee is. I see if I have enough inputs already to cover the fee. If I do, I return. I'm done. Otherwise, I look up the UTXO. Well, first of all, I calculate what the address is for my private key. I get an instance of a locking script for that public or for that address. I get an instance of an unlocking script for that address. Then I figure out how many Satoshis do I need to put into a UTXO to pay for this transaction. Build the template for my transaction, my funding transaction, adding one output that is the amount that I need and another output that's just change. I load up a bunch of my existing UTXOs to make sure that I've got enough to cover the amount that this transaction is putting out. So for that, I'm looping over, look it up. Because there's concurrency issues, I need to make sure I can lock this transaction or this output. If I can't lock it, I go to the next one. I add the input to my transaction. I can recalculate the fee to make sure I've got enough inputs. If I do have enough inputs, I break out of this loop. If I don't have enough inputs, I loop back over again. Then we call the fee method, which will update my change output to have the appropriate change in it. Again, this is for the funding transaction. Then I sign my transaction. Then either we need to broadcast that transaction at this point right here, so that it exists, and then just add it in and we broadcast this transaction normally, or we use some sort of beef mechanism to broadcast this transaction with all its parents. And that decision is still to come, but here is our fund transaction method. Okay, I guess that's it for now. If I've got any other public topic, I will try and throw another one out, but for now, this is it. Talk to everyone later. Bye-bye.